Hi, good morning all. I will start. Seems like everyone has participated to the discussion. Uh, no, say, can we start or any other?
Yeah, Ani,
I will.
you have anything?
Uh, Today I am going to discuss with you regarding the Android memory profiling related things. In here, we have done the memory profiling for merchant app, and also we have had some discussions with Sai also regarding our uh, findings, and also combining those his and our findings, I will plan to do the today's discussion. This actually discussion. We are also finding profiling related things. If you have some any new things to add, you can add those things also. Um First, I will explain you regarding the what is memory leaking and how that can be happen. The memory leaking is we all know in the Java or Kotlin we have a garbage collector. Uh, in the but in the memory leak can be happen for Java and Kotlin languages. Because of that, garbage collector can't identify some kind of object that is not a valid still also. Because of that, garbage collector can't collect those kind of object, and they will retain as long as the app is in the main uh, program foreground or background. After killing that one, all the objects are get killed. uh, in the C or C++, we know we want to intentionally add the garbage collection, but in the Java or Kotlin, we do not want to intentionally add those collections. It uh, automatically add in those things. Uh, First, I will demo you to how to do the memory profiling in the Android Studio. This is the newest version of the Android Studio Giraffe. In the previously, we do the our experiment using the some old Android version, the previous Android version. But in this version, we have some new things adding for the Android profiler. First, we need to choose a build variant as a debug version. We want debug version to do the memory profiling, and then in here we can start the memory profiler. It has a low overhead and the complete data. In the low overhead, we can't identify the resources like battery consumption thing. We can't identify here if we do the profiling using the low overhead. In the with the complete data, that also can identify. Because of that, I will profile my app using the complete data. Uh, Now you can see my app has open, and also this is the memory profiler. In the top you can see the CPU usages of the app, and also the second you can see the memory, and then you can see the energy means battery and those kind of consumptions. The main thing we want to look at the memory things. In here you can see I am in home page of the merchant app. when I am retrieving to from another page, here you can see the in the pink dot shows the our clicking activities, and also when we are moving to another activity, you can see uh, it takes some CPU usage, and also the memory also high compared with this one, because in this activity we are loading SKUs from the backend, and also those are stored there. Because of that, it will allocate some memory for that one, and also the energy also takes, because we are doing some memory network calls and those kind of things. Because of that one, it will consume some our battery and those energy resources. And in that in the in here, the pink dotted noted the our clicking patterns. When we are clicking, it will denote like this. And also here you can see the our current activity. I in the first I located in the main activity, and after that it is stop. And then when I move to the menu manager, it will redirect to the SKU activity. In the top of that, you can see the what activity we are in actually. Then I want to I will first explain you the how to identify the ANR using the profiler. When we are clicking the CPU tab, here we can see the our running threads. We do not want to allocate more time from the main thread. If we allocate around 5 seconds from the main thread, it will affect for the ANRs. Because of that one, we will when we are developing the applications, we want to make sure that our main thread blocking time reduced to the more than 5 seconds. Otherwise it will affect for the memory leaks. In here we are allocating around millisecond time for our main thread. In other thread also, here you can see we are doing some background network calls using the background thread. Then those kind of thread also allocating some time for that task as well. When we are doing the network calls and those kind of things, we should not want to add those things to the main thread. We want to separate those kind of activities to the another thread, like IO or likewise we can add those kind of network calls to the separate thread. When we want to do the UI update, then we can use the main thread. That's the way we can identify the ANRs from the memory profiler. If you have any questions, you can ask.
ඒ කියන්නේ චමෝද මේ මේන් ත්‍රෙඩ් එකේ තප්පර දෙක තුනකට වැඩි මොකක් හරි එකක් තියෙනවා කියන්නේ එතන ANR එකක් කියලාද අපි identify කරගන්නේ
minimum value එක 5 second කියලා තමයි කියලා තියෙන්නේ. 5 second වගේ block වුණොත් ඉතින් ANR එකක්
වෙන්න පුළුවන්.
ඔව්. ඊට පස්සේ so then the most important thing is the memory. I will show some I will add the Jamboard to show something for you. as an example, when we are in assume that we have activities, two activities like A and B, right? In here, when we are in another activity, we are in activity A, that memory consumption is assume that 100 MB, right? And also after navigate to the another activity, it will want some more memory, because some scenarios we are loading some data, those kind of thing can be happen. Then when we are moving to the activity B, that memory can be increased, either increase or decrease according to the scenarios that can be happen. Assume that when we are loading some more data to the RAM, then it will definitely increase like this, and also it will stable like this way in the B activity. After the B activity, if we navigate to the again to the activity A, right, again to the activity A, that memory should be free up, right? It is same as the 100 MB. Most probably it is better if we can reduce to the 100 MB, but some kind of allocations can be there. Because of that, Sai also mentioned that one, it is better if we can reduce like this kind of pattern here, up to this one, or it is better, but it is not good if we are moving to the activity A. If we retain the same memory, this is not a good practice. These two memory consumptions are okay, but these kind of memory consumptions most probably affect for the memory leaks. These kind of things we can identify using the Android profile memory. In here you can see we are in main activity. It will allocate 184 MB, and when we are moving to the SKU activity, it will allocate at 198. That can be happen in our application because it will load the SKUs from the backend side. Okay, then I will continue the my profiler, and after that I will redirect to our main activity. Now you can see it will reduce the in here you can see it will reduce the that allocated memory for the SKU activity, because now we are in the main activity, right? And also in the detail view, we can see by clicking the this memory tab. In here you can see the detail view, like in total allocations and how much allocated for Java, native, graphics, and those kind of things we can see. And also in here you can see we are destroyed the main activity and then started the SKU activity. Then it will reduce that SKU activity related memories. And also the garbage collection is manually happening, no? According to the device, that can be happening randomly. In here you can see the garbage collection happen here. Here you can see the dustbin icon. This denoted the garbage collection happening when we redirect to the SKU activity to the main activity. the intentionally also we can add the garbage collection, like by clicking this one. In here you can see now it will denote the it has happened the garbage collection, and it reduce the more memory from the device. But when we are reducing those collected related object, if that exists the memory leak, those kind of object we can't remove by clicking the this post garbage collection icon, because due to that one we will there can be happen the memory leaks. And also here you can see the energy related things when we are doing a network call and those things. This kind of memory energy consumption can be happen. Then I will show you the regarding the app inspection thing. Using the app inspection we can identify our net. There are several inspectors there, database inspector, network inspector, and the background task inspector. In here if we have some local database maintaining those kind of databases, we can identify here preferences and those kind of things we can identify using the database inspector. In the network calls we can identify what are the network calls that happen in our application. In here we are sending every 10-second call to page the orders. In here you can see the network calls happening every 10 seconds. And also if we are clicking some item here, you can see the overview of that network call and what is the status and content type, those kind of, and URL also you can see here. In here we can see the response of the
සමග උතන්ට ගියේ කොහමද?
ගියයි මෙතන දැන් මේ ජිරාෆ් එකේ පොඩ්ඩක් වෙනස්. මෙතන tool windows වල මේ app inspection වල
inspection හරියට.
Okay. In here we can identify the responses and also request how that memory call happening, call stack, and those kind of thing we can identify using the network call. This network inspector is very important to identify the network calls. In Mr. Kenley, if we can have some 2 network call for same time, that kind of thing we can identify. And also the background task also we can identify. In here we have Firebase Analytics Worker and also the alarm manager for do the 10-second call for fetching up the orders. And also we are sending another call like this to get the merchant status from the backend. Those kind of thing we can identify using the network inspector. And also in here you can see the size of that response, and also the status, and also this time is very important. If we are we can identify what are the network calls that we do more time, and then after that after identifying those kind of network calls, we want to figure out solution in the backend side, or some other architectural designs we want to figure out for minimizing that request time. Those kind of things we can do using the network inspector. Those are the things actually in the that I want to discuss here. Then I will remove some. Yeah, I got.
නමුත් මේ ඔය එනර්ජි එකේ අපිට දැනගන්න පුළුවන්ද කොහෙන්ද මේ එනර්ජි මේ කන්සප්ෂන් එක යන්නේ කියලා ක්ලාස් එකක් හරි මොනවා හරි මෙතඩ් එකක් කරලා
එහෙම ඒ කියන්නේ මේක එතර ලොකු දෙයක් නම් මෙතන දැනගන්න බෑ. අර CPU එකයි network
විතරයි ගන්න.
ඔව් අර එහෙම ගන්න පුළුවන්. ඊට පස්සේ I think අර activity එක මොකක්ද කියලා ගන්න පුළුවන්. ඉන්න
එතන ඒක මොකක්ද activity කියලා බලලා අපි මේ බලාගෙන යනවා.
ඔව් එතනයි මෙමරි එකයි ඔක්කොම තුනම එක ළඟ තියෙන නිසා අපිට අයිඩෙන්ටිෆයි කරගන්න පුළුවන්. හැබැයි කියන්නේ මෙමරි එක මේවට now I will show you the how to identify the memory leaking, and also what are the tools that we can use for identify those kind of leaks. For the demo purpose, I have created a separate application for demo that one. Intentionally add the memory leak here. In here you can see there are two activities there, main activity and also the leaking activity there. In here what we are doing is the opening the that leaking activity. Inside the leaking activity I have created the Kotlin object, singleton Kotlin object, and also I have created the mutable array list listeners, and also there are two functions to register the listeners and also unregister the listeners. I have created that interface for using this global listener to the another functions. In here this global singleton exists until the app is alive, because this global singleton instance, it is actually one object. In the leaking activity, in the onStart method I have registered the listener, but in the onStop method I haven't unregistered that listener. Then we will see that kind of memory leaks can be identified memory profiler. I have then now I will run my profiler. Okay, okay, profiler has restarting the profiler. If we want to add a new session, by clicking this plus button we can add the session here. Okay, now it's fine. Then this is the sample app that I created to demonstrate the memory consumptions and the memory leaking things. This is my main activity. In here you can see now I am in main activity. When I am moving to the leak activity, then it will call the only start and then register the listener. Still we can't identify there is a memory leak or any kind of thing happen. Then after I several time I will start that activity. After that I will pause the profiler and then get the heap down, and after clicking the I will start the recording. After getting the heap down, we can identify the memory if there are some memory leaks happening or not. Let's see after getting the heap dump what will happen. Here you can see there are two leaks happening there because I have clicked that button in 2 times. Because of that it will show the 2 leaks happen there. In here you can see all the library related classes and those kind of all the things we can see here, but we want to here want regarding our classes. Because of that I will filter so project classes. Then we can reduce the number of classes because the library related things is not mandatory for this time. Because of that, and I filter like this. Then in here you can see there is a one leak here. In the in here you can identify what is the activity there, and also here you can see allocations too. These allocations too happen because I have clicked that icon, click the button in 2 times. By clicking the leaking activity, here you can see those instances that created by clicking the button. In here you can see that listener retains some memory there, and also after navigate into the main activity, that listener is still there because we are not unregistered that listener. Due to that one, this memory leak happen. Here you can see the retained memory and depth, those kind of things we can identify here. Here you can see that the listener is still there when we are when we move to the main activity. That is the way actually we can identify the memory leaks using the memory profiler. Now let's do a solution for that one, and then again I will run that one and see whether still the memory leak is there or not. Then I run again. Okay, then I will click the activity and also back and also again click. Okay, then I will pause the profiler, then click the memory, and then I will capture the heap dump. Okay, now you can see 0 leaks there because we have unregistered the listener when we are stopping the applications. this is the one way we can identify the memory leaks. I will show you one other way to identify memory leaks. In here, the problem was that in some time we want to get the heap dump, and then we want to identify the if there are memory leaks or not. But there is a famous library to identify the memory leaks called leak canary. Using the leak canary, we can identify memory leaks. I will show how to add the leak canary to our application, and how to find those memory leaks there. Using the getting started, they are showing this dependency there. We want to add this dependency to our build.gradle file. That's only thing we want to do here. I will show how to add those dependency inside the build.gradle file. I can add this line, and also then after that we can sync in. Okay, now it's fine. Then I will debug the application using the dictionary. We can identify the memory leaks, but we do not want to look at the memory profiler. Using only the application, we can identify memory leaks there. I will show that how we can identify those memory leaks using the leak canary. First, I will comment this on stop method, because we want to get memory leak there. Then I will debug it. Okay, now this is the way that application show here. Then I am clicking the leak activity, and also again clicking. Okay, now in here you can see there is a notification there. 5 retained objects, tap to dump here. That this is the way that identify the memory leaks from using the leak canary. It will automatically identify the memory leak. We do not want to get the heap dump from each and every time. Using this one, very easily we can identify there is a memory leak. Then I am clicking this one, and here you can see it dumped the memory there. Here analyzing the heap dump. After the analyzing the heap dump, it will show the what is the place that will happen the memory leak. So that after analyzing the heap dump, it will take some time to analyze. it will take some time. Meanwhile, I will demo you to how to do the static code analysis using the Android Studio. After that, I think hopefully it will analyze the heap dump, and then I will show this one after that. For the static code analysis, we can in the Android Studio we have a tool for called SonarLint. Using that SonarLint, we can identify some code improvements there. We can install that plugin using by navigating to the setting. Inside the settings we have plugins, and search the SonarLint here. Then you can easily install that plugin to your Android Studio. After installing the SonarLint, click the OK, and then in the first time you want to restart the application. After that, we can get the SonarLint using the view tool windows, and here you can see the SonarLint here. In here, this is the SonarLint. In here you can see the current file improvements, and also if we want to get the report like analyzing the entire project, those kind of things can be do there. And also if we have some Sonar Cube cloud environment, that environment also here can connect. I think when we do that kind of integration, it can be identify more improvements, because in here we are using some open source things. If we connect to this some kind of server, then it will most probably identify more Sonar Cube things. And also here we can add some file exclusion if we do not want to do the Sonar Cube and those kind of things. In here you can see the current file. They are showing some suggestions, like what we can see here. What they are saying is section of code should not be commented out, right? This they are saying this kind of things we do not want to comment that one. And also in here you can see they are mentioning function should not be empty. If we are creating the empty function, they are just to add even the comment also. Then that warning removed, right? And also if we remove this line, so if we remove this comment, then that line also removed. Likewise, we can identify the current file related improvements. And also if we want to get the report, in here you can see analyze all project files. By clicking this one, it will analyze all the project files, and it will identify the these files need to be do this one. Like in here you can see it will identify all of the files, and separately they are mentioning some improvements there. And also this is the way that we do the static code analysis using the SonarLint. and also there are some other things also in here. If we are not if we want to get the improvements from the uncommitted files, we can do that one as well. Likewise, there are more facilities there. Using that one, we can do a better code by repairing those comments. Still, if you have any questions, you can ask. Still in here now, I will show that. In here you can see it will create a separate Apple Lee Canary, and by clicking this one, here you can identify the there are two instances there that will do the memory leak. By clicking this one, you can identify the what is the exact reason for that, and also the retaining memory for that allocated for that object. Those kind of thing we can identify. Here you can see leak in yes object which was watching this, because likewise by reading this one, we can identify the what is the line that we want to know that will affect for the memory leaks. Those kind of things we can identify. Actually, there is no exact way to identify the memory leaks and those kind of things. If we have a large project, then it has some inheritance there, and also project is big, and then it is some kind of hard actually identify the memory leaks. But if we are doing the memory leak analysis from the beginning of that, it is actually very easy to maintain in the with app that will not affect memory leaks. In here also we can identify the memory leaks. The advantages of this Lee Canary application is to we do not want to get heap dump from every time. Each and every time it will automatically detect there is a memory leak there, and those kind of thing we can identify here. Yeah, these are the things that I want to discuss today. If you guys have anything else to discuss, we can discuss. And also Sai mentioned that if we are sending the APK to the QAs, integrate that build APK with the Lee Canary, and then QAs also can identify there are some memory leaks and those kind of things. That's a suggestion from the Sai. But we are not in our side, actually we are not following that one. I think it will be better. I don't know with the QA side how they manage those kind of things, but I mentioned that one as well. Yeah, if you need anything else to discuss, we can discuss those things.
This tool is available for iOS also.
Android විතරක් දැනට අවබෝධ
iOS එක නම් ලී කැනරිද එක නම් මන් දන්නයි මං ඇන්ඩ්‍රොයිඩ් පැත්තම තමයි බලන්ගේ
හරි හවුද
Xcode වල instrumentation කියලා එකක් තියෙනවනේ.
ඒක තියෙනවා ඒක තියෙනවා
ඒක තමයි කොහොමද iOS වලට පාවිච්චි
යා ඒක යූස් කරන මම බැලුවා අර සෝනා කියුබ් එක යූස් කරනවා අපි මේ එකට පොඩ්ඩක් මේක දෙකේම එකම මේ වුණොත්
Sona Cube එක නම්
documentation
එකක් තියෙනවද දන්නේ නැහැ. ඒක කැටි හැබැයි.
මේක තියෙනවා මේ ස්විෆ්ට් ලින්ක් කියලා එකක් තියෙනවා.
අනිත් එක මේ චම මේ අපිට Sona Cube එකක් තියෙනවා.
අපි ඒකටයි කනෙක්ට් කරලා බලමු මොනවද තියෙනවද ඩිස්කස් කරන්න
අපි Android එක Sona Cube එක අනිවාර්යෙන් ඉන්ටිග්‍රේට් කරගන්න ඕනේ. ඊට ඩයටුත් මේ තියෙනවා දාලා කිව්වා ඒක අපි මේ පැත්තෙන් කරගෙන යන් කියලා. ඒකයි ඩයටුත් නෑ Sona Cube එකම අර රිපෝටින් ටූල් එකක් විදිහට අපිට යූස් කරගන්න පුළුවන්. ඒතකොට iOS උත් ඒකටම ඉන්ටිග්‍රේට් කරන්න දෙනවා නම් හොඳයි කියලා. බට් මාත් චෙක් කරලා තිබ්බේ නෑ ඒක ඉන්ටිග්‍රේට් කරන්න පුළුවන්ද බැරිද කියලා. Android එකෙන් අපි ස්ටාර්ට් කරමු. Yes. චමෝද already කරනවා නේද?
මොකදයි
already කරනවාද Sona Cube එක කරලාද තියෙන්නේ?
ඔව් ඒ කියන්නේ අපි කරනවා අර මේ cloud එකට කනෙක්ට් කරේ නැහැ සර්වර් එකට
okay.
තමයි කරන්නේ අතට එකකින් credentials ඉල්ලගෙන එකට කනෙක්ට් කරලා බලන්න
okay.
හරි වෙන මොකුත් කතා කරන්න නැත්නම් අපි මේක find up කරමු
Okay, come on, thanks.
Okay, thanks Chaman. Good
okay
job.
bye
Yeah, thanks Chaman.
Thank you.
Bye.
Thank you Chaman.
Thank you.